All right, so next thing I'm going to show you is something that can be a little scary, especially when you're only using instruments to fly, is what to do if you actually lose some of your instruments. Now, losing certain instruments may not be as bad as losing others. As in, if I lose my airspeed indicator, my altimeter, and VSI, that's not as terrible because I still have my standby airspeed and standby altimeter, and my pitch attitude is my attitude indicator is my primary reference. Now the problem is if I lose my attitude indicator, I do have a standby that I can use, but it's not as sensitive as my primary, and my interpretation, my scan has now changed. So if I'm using a hub and spoke method, I've now changed to interpreting these three instruments at the bottom here, my standbys, and then moving up and down between the PFD and the MFD and the standbys. So I've increased the amount of scanning I'm actually doing. What I like to do is in the middle of my flight, when I take off and I go straight in level after I've done my cruise checklist, is set my standby attitude indicator. And what I like doing is, even though I'm indicating 2.5 degrees of pitch up for my cruise, I like setting the standby attitude indicator to 0 pitch, because that actually indicates to me, it helps me with my interpretation, and in terms of sensitivity, determining that I'm at the pitch that I want to be for straight and level at 100 knots at 2350 RPM. So another thing to understand is that in IFR, if you lose your instruments, regulations dictate that we must tell ATC that we have a system malfunction. If you do that, when you do that, you got to be specific. Air traffic control, you got to remember that most air traffic controllers are not pilots. So if you tell them you have an AHARS failure, that means nothing to them. You need to tell them exactly what happened. I have lost my primary attitude indicator. And don't be vague either. You want to tell them, I've lost my primary attitude indicator, I have a standby, and I'd like to declare an emergency. If you've lost your primary flight instruments, this becomes an emergency because the safety of flight is now in jeopardy, especially if you're a low-time pilot, a low-time instrument pilot. Now, I have over 4,000 hours. I'm still declaring an emergency because I would like priority to get back to the airport. And I don't want anyone to ever be scared about declaring an emergency. It's a safety function. Get down to the ground quick as possible. And air traffic control may ask you for some paperwork. They may just ask you a couple of questions of what happened, but that's about it. My job is to try and get safely on the ground. So don't ever be scared to declare an emergency. So let's see what happens. Let's see what happens if I lose my primary attitude indicator. If you look at the PFD, you'll notice what happened. All right, there it is. So what you've seen now is my screen's gone quite blank, and I've lost my primary reference. So now I've shifted my view to using my standby attitude indicator as my primary pitch reference, primary hub reference for my scan. So I'm still maintaining 2350 RPM. I got my little orange dot on the white line, the middle line, because that's what I set for my level pitch. And then I can go back up to my attitude indicator, my PFD, and check my airspeed, my altimeter, and my VSI to make sure I'm actually still getting what I want. And then I have my CDI reference and the heading indicator, my VOR. So in this case, you want to make very small adjustments, and you'll notify air traffic control. Daytona approach, Riddle 462. I have just lost my primary attitude indicator. I have a standby that I'm using, but it's not as sensitive. I need like to declare an emergency and return back to Daytona.
Riddle 462, roger, say souls on board and fuel on board.
Riddle 462, we have 2 souls on board and we have 3.5 hours of fuel left.
Riddle 462, roger, we have your emergency on file, fly heading 180. This will be vectors for visual into Daytona.
Riddle 462, 180, visual vectors for Daytona. All right, 180. So right now, our attitude indicator, we don't actually, if you notice our heading indicator, we don't have any numbers on there. So our primary heading reference is our mag compass. So they want me to turn to 180. So conduct a standard rate turn, 180, going directly south. If you're going south, we have to overshoot south by half our latitude plus 15, which is 30 degrees for the Daytona area. So I'm actually going to turn to 210 when my heading indicator indicates 21, my mag compass indicates 210, and then roll out, because that should give me 180 because of the lag and lead errors. So I'm going to roll out here. And you'll notice my mag compass is actually swung back to 185. That's not what I want. So I'm sitting about 180. I want 180, so I'll turn half standard rate turn back about 2 seconds, since a standard rate turn is 3 degrees per second. So I'll make small adjustments, and now I'm on 180. So I'll maintain this heading, maintain 3,000 feet, and just wait for ATC to tell me what to do. I'm still scanning. My scan is quite significant now, because I'm going attitude indicator, airspeed, attitude indicator, altimeter, attitude indicator, mag compass. So there's 180. I'm actually drifting now, so I got to turn back. The mag compass isn't as sensitive as your heading indicator, and the errors can be relatively larger than the heading indicator. So make small adjustments.
Riddle 462, turn right heading 210, descend and maintain 2000.
Riddle 462, turn right 210, descend and maintain 2000.
Okay, first I'm going to turn right 210. So we have about 30 degrees, so that's a 10-second turn. Turn right, 10 seconds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, I'll overshot a little bit, so I'm going to fine-tune adjust. And there's 210. And descend and maintain 2,000 feet. So I'm going to reduce the power. I know it's about 2,000 RPM. And as I do that, I know the nose is going to drop, but I already have it trimmed. For 100 knots. So I'll put 2,000 feet, 2,000 RPM, and I will slowly let the nose drop by itself by just holding my back pressure that I already had for level flight. And the nose should drop by itself for 100 knots because it was trimmed for 100 knots. And then I can make fine, small adjustments from there. So key is to not overcorrect and understand the flight control inputs. You don't want to push down when descending. You don't want to push the yoke down. Just reduce the power. The nose will automatically reduce, the pitch will automatically decrease. Keep that scan going, back up from your attitude indicator up to your heading indicator, your mag compass, and again, making small adjustments. So 210, I want to make sure I'm descending down to 2,000 feet and trim the aircraft out. So it looks like my white dot, my little red dot, is just below the white 0 pitch line on my standby attitude indicator.
Riddle 462, bases were reported at 2,400. Advise if you encounter VFR.
Riddle 462, what advice would VFR?
So ATC has helped me out. I declared an emergency. They're doing all they can to help me get to an area of VFR so that I can transition to VFR flying. Now my airspeed is 100 knots. So I'm still good on my airspeed. I might be a little too fast, so I'll reduce by 50 RPM. Again, the nose will drop by itself. Don't force the nose down. Don't push the nose down. Just let the nose drop by itself when you reduce the power, and then see what pitch and what rate of descent it gives you. You want to kind of maintain about 500 to 600 feet per minute on the descent. And we can use our VSI up here to determine our rate of descent. So still on the 210 heading, still descending. There's VFR.
Daytime approach, Riddle 462 is VFR.
Riddle 462, roger. Maintain your present heading, and we'll get you vectors for runway 7 left as soon as possible.
Riddle 462, maintain present heading, and then expect vector 7 left.
Okay, now VFR, I'll transition to outside flying. I'm maintaining 2,000 feet. Now my primary attitude, my reference will be the horizon. And since I am VFR now, it becomes a lot easier to fly the airplane. So basic knowledge of a partial panel and using your primary attitude indicator, basic knowledge of how to fly the airplane, is crucial to the safe flying of the aircraft, because ATC can then vector you and you can fly the aircraft safely to a point where you can maintain VFR and get back in land as soon as practical. So basic things about flying partial panel: small changes. Set your pitch reference to help you out prior, after you've done your cruise checklist. Like I said, I'd set the red dot on my standby to the 0 mark line. So that helps me knowing that that's level flight. Since it's not as sensitive and the markings aren't as the incremental markings aren't as small as on my primary attitude indicator. Small adjustments: know your pitch and power settings. Know your power settings. That's going to be very important. What gives you level flight at 100 knots? What gives you 500 feet per minute descent at 100 knots? So knowledge and memorization of those power setting numbers and your pitch attitudes is crucial to helping you fly the aircraft safely during partial panel. Remember to report the failure to air traffic control, be specific, and tell them exactly what you want to do, and declare an emergency, since this is a safety of flight function and you've lost your primary reference of flying the airplane.